Okay, hello. I think I'm live. Right. Let's see. Just setting myself up here. Bear with, I'm just doing off-screen bits and bobs. Oops. That one. There we go. Right. Okay, so left you all last time with crashing animation. I'm not entirely sure. I was just literally just a minute ago running it again, and this time I was printing out the year and the month. You can see that it goes to 2014, January 2014, which I can't understand is because I've got this line here which should exit if it's greater than 2013, which 2014 in my logic is. So I'm a bit perplexed as to why that's failing to stop. But let's not worry about that at this particular point in time. What I'm planning on doing, I've been having to think about where to go with this, is that I'm going to create this into a spiral, and then once that is complete, I'll put the global temperature, which I've got data for back at least to the 19th century, a spiral sitting beside it, so you'll have dual spirals, and you can hopefully be able to make out a correlation between the temperature and the sea ice cover. So we'll go with that. Now, because this is only Arctic, it's not going to be the same as the spiral that I have done for global sea ice, which has a nice crashing again. What am I doing? Trying to talk and think at the same time. Bad idea. So in my previous spirals, I had a let's have a look. So in my previous spirals, which is, for example, this one, the outer ring is the global sea ice area, but we've only got Arctic sea ice area, so it'll look something like this in the spiral, which is a funny off-centered lobe thing, and you can see that it kind of makes a dip into the at the September minimum. There's a bit of a dip going on there, and that's because we're plotting a sine wave, I believe, onto a polar coordinate, and it makes this interesting kind of dip in there. So that's what I'm expecting to see in the once we've got the result done. So let's put that to the side, and so let's crack on with that. So left is with this animation, which is just scrolling continuously to the right, showing all of the seasonal variations of the Arctic sea ice. So it looks like they've done quite a nice job on recreating the centuries-long data that they received from ship's logs, which must have been quite a difficult challenge. I'll be interested in reading up on how they actually go about doing that. But let's play with the data in the meantime, and then we can find out how they did it. So you can see down here, I didn't realize that after I'd watched the recorded video, that the code down here, the output down here, was hidden by the Wirecast watermark. So I wonder if I can adjust the position of that, make it bigger. I know that, but can I actually move it? I'm not entirely sure. There doesn't seem to be any actual options or anything like that, but we'll keep badgering on anyway. I'll just be aware of the watermark as I do it now. Okay, right, so to make a that's crashed again. Yes. So to do a spiral, the idea is, instead of scrolling to the right, we go round in a circle, and that's a simple case of given an angle, plot the coordinates, and you just simply do the sine of x and the cos of y. Well, sorry, the sine of the angle gives you the x, and the cos of the angle gives you the y. So cosine and sine, obviously. So the way to do that on computing is, because we don't use degrees, we use radians. We have to convert everything to radians, or you just work with radians to start with. What I want to do is make it do a full circle for every year. So obviously we've got 12 records per year, so we want 1/12 of a circle as your angle. So the way to so what we'll be doing is that we'll be working out once we've worked out the month value, then we can work out what angle that month is going to be. Excuse me. Just so so obviously it's going to be 1/12 of a circle, and because we're I'm going to be working in radians, because there's no point in working out angles and then converting it to radians. You can just do it directly into radians. One full circle is 2 pi radians, so it's obviously going to be 1/6 of pi is our angle per month. So let's work that out. So it's going to be a floating point value, so float, and we'll go with angle, which would be equal to basically the month times pi. Now there we are. So that's great, easy as that. No, it's not. It'll be the month times 2 pi, isn't it? No, it's not. God, no, divided by. My word, I'm not even thinking straight. So it'll be 2 pi divided by the month. Right. This talking and thinking at the same time is a new concept for me. Right. So it's 2 times pi divided by the month. So now we've got the angle, great, fine. Then finding the point of x and point of y is going to involve, so it's going to be, y is going to be, sorry, the ice area is now going to be the radius from the center. So and the angle, so we'll be able to, so we've got the radius here, which will be the ice area. We know what the angle is, we've got that at the top. So all we need to do is work out what our new x and y is going to be. So obviously x isn't going to increment by 1 every time anymore, so let's get rid of that. X is now going to be calculated each time, so that's going to sit just here, and obviously it's not going to be an integer anymore either, so it's going to be a floating point value. And we also, because X is not a predictable value, well, not as predictable as it used to be, we also need to remember the previous value of X as well, just like we've just done with the last value of Y. So let's do that. Okay, so now we need to work out, given an ice area, what the position. First of all, actually, what we want to do is create a new variable called the radius. Now the radius is just going to be a scaled value of the ice area, so it's just going to be equal to ice area times, let's go with 50 is quite a lot higher up the screen, then we're going to be doing a circle, we're going to be using about half the space, so let's go with 20. I think 20 would be a reasonably good guesstimate to start with on the scaling of the ice area. So then to find out the position of X and Y, and I like to work with X and Y, not Y and X, so let's just move those around just so my brain doesn't have to think too hard. So we need to, to find the X value of that, first of all we need to know the center of the point of the center of the circle, and at this stage we'll just do a simple spiral in the middle of the screen. So we'll be able to go with float center X equals the width divided by 2, and I'll do another one for Y, which will be exactly the same number, but we're going to start playing around with that, so might as well do a decent job to start with. Height divided by 2. Now, so X is obviously going to be the center X plus the sine. Is it going to let me? I think it's just literally that good sine of the angle times the radius, and so Y is also going to be the exact same, except it's going to be cosine. No, I've got that wrong. Bad. No, it's the cosine is X and the sine is Y. Into Y plus, hey, the sine of the angle times the radius, and we'll change that to the cosine. The way that I failed to remember it just before is that cosine of X is a harsh kind of sound, cos and X, whilst Y is sine and Y. It's a nice, more gentle sound. That's the way I've always remembered it, except I just completely forgot it just before. So X and Y, the cosine, the sine, angle times radius, center X and Y, that starts with there. So that's going to be the same logic, I think. So in this time, now we're going to be basically not worrying about scaling there. So it's literally just going to be X height minus the last. Oh, it's going to be last X there, isn't it? Yes, last X height minus the last X, and then it's going to be just plain old X and height minus Y. I believe in that. Should do that. So that's great. Now obviously we've also mucked about with the start month and stuff, so we want to be able to do a spiral, and we're going to draw every value, so we're not going to have a different start month anymore. It's always going to be the start month of 1. So if free count is greater than 50. So we'll get rid of that logic, and it's just going to be 1. Starting off with 1, going to the end month, and it's year 1850 plus a month divided by 2, 12 even. Actually, I think that's right. That's going to draw something quite interesting. We'll see what it looks like, but I'm not putting too much hope on it actually doing anything that we want it to do, but we'll give it a go. I'm just framing it so if I do fail, I don't. I'm expecting to fail. Okay, I said that. Let's see what happens. That's certainly quite interesting. What, pray tell, is going on there? Looks like I'm only drawing half the spiral. Okay, what am I doing wrong? So something about my angle. Is it 2 times pi? Oh, maybe 2 times pi divided by 12 a month. Is that going to give me an actually sensible value? So if I go... just using a calculator here. Right, so 2 times pi. Try that again. 2 times pi is 6.2, and if I divide that by 12, I end up with 0.52. I think I've got that wrong. How have I got that wrong? Oh, of course. Duh. Dividing it by 12 is just going to make it smaller and smaller and smaller. So what I actually should be doing is figuring out what 1/12 of a circle is. So we want angle of 1 month equals 2 times pi divided by 12. Let's make it a little easier to read. And then the angle is the month times the angle of 1 month. Not the angel, the angle of 1 month. I think that's much better. So let's give that a bash. Hey, now we're cooking. How about that? So let's sit and watch that, and certainly very consistent. Yeah, my laptop fan's just kicked in. It's rendering away quite nicely. So you can think that every 30 times a second it needs to draw every single line right from the start. That's because we clear the frame and then draw it every time. But it looks like we're not actually doing much there. The reason why I want to do that is that when we actually start to add further details to it, you want those details to, especially if they're moving around the animation, you don't want them to leave a trail or anything like that. So it does mean that, yeah, I think I can actually see the rendering slowing down. So we're coming up to, can't really quite tell. We haven't got to the 21st century yet. That's all I can say. So yes, I think it's starting to slow down in rendering. You can kind of see the odd line drawing on there. Oh, it's gone up a bit there. It's interesting. What are we up to? Still in the 20th century. We haven't made it to the 21st century yet. Right, I think I might actually. Oh no, I just finally made it to the 21st century. There we go, it's starting to come around on the inside there. There we go. Yeah, so we're obviously going to have to make this draw quite quickly, otherwise the animation is going to be very, very boring. Right, there we go. So this is the little indentation I was expecting to see. So what that gets, we only got up to 2013. So what I can do is add satellite data to this. So I can either just keep them going in by month, and you'll see, basically a 12-sided figure. It's coming into the dodecahedron. That's a 3D 12-sided figure. So what I could do is add the average of each month after 2013, or I actually display the full data. So once you see it in these 12 sides, we can actually then render it with a trail that looks like the animation I previously showed. Have I still got that on the screen? I'll close that. So those are the options that we can do. So what I'd ideally like to have is have this spiral sitting here, and then having the actually we can have a look at Climate Labs, because they've got the exact spiral I'm talking about with right here. So this is a spiral by Mr. Ed Hawkins. So when did that start? That was 1850, so that's quite useful. So it'll have, it'll go kind of like that, sitting on just to the right or the left, wherever we decide. And then as the temperature increases, we should see the ice decrease. I'm wondering if that'll be quite an interesting visual. So that's a possibility, I think. Okay, right. That's a good start. Still crashing because it's not detecting that the year has gone greater than 2013, which is bizarre considering it's down here quite obviously 2014. So unless I'm calculating the year after that, which I'm not, I don't get that. Really don't get that. Right, let's close that, cancel. Kind of worrying, really. What's wrong with that? Alright, so we've got ourselves a nice spiral. I'm just wondering, what I would like to see is knock that back down to a stroke weight of 1. I'm not entirely sure if you guys will be able to see it on the stream, but we'll play that and we should see a little bit more detail in the spiral. So I think we definitely need to have a dual spiral, because to be honest this is kind of boring. So if we have the temperature spiral sitting beside this spiral, which is a bit more interesting to view, so let's put that over there actually, and we'll just do that. So a bit more variable than the seaice spiral. So So I guess it'll only become kind of interesting once the year hits around about 2013. So that comes in 2013. So there's quite an increase. So it's March 2017. You should do an update now because we've all gone right round to December now, but I don't think it increased too much. But it should show a correlation between the increase on this side and the loss of ice on this side. But what we'll do is we'll do that and then we'll slow it down once it gets to the 21st century, and then slow it down even further closer to the current date. So let's go with that. Actually, what we could do, so the next step I think would be to colour the line as we increase in time. So there's quite a nice little function that processing provides us with that. It's the, let's see, processing reference. So bizarre name though, and it is LERP, L-E-R-P, LERP color. Now, what LERP is, let's have a Google for LERP. LERP is linear interpolation. So given a point, first point and a second point, and a number between 0 and 1, it'll find a line, it'll find a point along that line, which is great for lines, and I have actually used that in other animations that I've done, but in this case we want to find a color between two colors. So we've got, so what we can do is, so for example they've got a from color and a to color, so that's the two colors that they've got in their example, and then the, what do we got, so you want to find 1/3 of the way between those two colors and 2/3 of the way between those two colors. That's your into A and into B. So this is their from color, that's their to color, and that's the colors in between. So that's what we'll do. So right, where are we? I am in here. Okay. So what we need to do is find out how far through we are, and that's basically based on month. Remember, month is a number between 1 and something like 5,000, however many months there are between 2013 and 1850. So I can actually find out directly from the data what. So if we've got each line is a month. So actually it's only 1,968. I don't know where I got 5,000 from. Oh, it's 5,000 something odd days. No, that's not even wrong. Number that just came out of my head for no reason. So 1,968. So basically, when we want to do a LERP color between 1 and 1,968. So we want to first of all find out the proportion of the way through the animation that we're doing. So that's quite straightforward to do. So it would be so float. We want we'll call it animation proportion. How about that? Anim proportion, which is 1,968. I'm going to get this around the wrong way. I can feel it. I want to go month divided by 1,968. So that should start off at basically 0 and end up as 1 as we approach the last month in the animation. So we've got that. Now we want to have a color, which is going to be, we'll call it line color. Oh, I'm British and I like my U's. equals lerp color. And we want our from color to be, gosh, how do we do color? I think it's just color like this. Is that right? Yeah, we'll go with that. Color, let's go from, argument's sake, oh, I don't know. What's a nice color? We'll go from green. 0,0,25. No, red, green, blue, isn't it? 255,0 to. Oh, how about red? Because that's another easy color to remember. 255,0, like that. And we want it to go to the animation proportion. Be nice if I had some proportion. Decent IntelliSense in this editor, but there is none, unfortunately. So now we've got a line color. So now what we do is we go just before we do the line. Well, in fact, we could have done it anywhere before this line, but we'll do it here because it makes sense, is to set the stroke color, I think it's just stroke, to be line color. I think that's right. Alright, let's see what that does. So that should start off as green and go steadily towards red, and that'll make some interesting colors along the way. So let's do that. So we're starting off at green. Got that bit right. Is it going to change color as we go along? Of course, there's 1,968 of these, and I don't know if I can spot any color changes just yet. The trouble with this is going to be extraordinarily slow. Well, especially when rendering it. We'll be able to get it set up to go a bit faster once we proceed with the code. But that looks basically green still. I got that calculation wrong. What are we up to? Can't really read that. It's just a whole bunch of random numbers. Okay. I'm not seeing any color difference there. I must have got this calculation wrong. So month divided by 1968. I wonder if that's because that's an integer and that's an integer. It's coming out as an integer. Let's put .0 on that. I think that forces it to be a float. And let's hit that again. And you know what I'm going to do? I'm going to speed it up by this nifty trick. Let's make it 10 times faster. That's going to go very quick. So what that's doing is it's skipping the, so the end month is going to be, no, that's going to look stupid. What we want to do is the end month here to increase by 10. So plus equals 10 is a nice shorthand way of saying end month equals end month plus 10. Right, let's give that a bash. That'll be a lot faster. There it goes. And we're getting some color now. So that's certainly changed the aspect of that animation entirely, hasn't it? So you can see that there is a drift towards red and towards the center up there, but it's interesting that it seems to, I'm thinking that's September, October, November, December, January, February. So February and March looks like it's actually growing, which is interesting. Whilst the September minimum is significantly shrinking. How curious. So I've got something really wrong. So that. Right. through now. We've got a nice, fast, reasonably colourful animation. Next step would be to just trying to decide whether to continue adding more things to this animation, or should I start including the global temperature? Get that sitting beside it as well, and then we can start adding some decoration, things like, you know, the month names and grid, not grid lines. It's going to be a spiral. It's going to be circles showing how, you know, showing what the area is. I think what I'll do is set, yeah, because what I actually want to do, I'm going to keep this stream down to an hour. I went a bit over that last time, so I've got so it's another half an hour to go. So I think inside half an hour I should be able to get the titles and stuff in. So let's put the titles of the month in. So now to do that, what we'll do is, in the very first thing that it does is draw the titles. So let's do that. So we want to do, say, render the months. So let's render months, month names. So that's a function that doesn't exist, so let's make it exist. It doesn't really matter. Right. So this is where we're going to get some reasonably interesting code going on here. So to be able to render text at an angle, what we have to do is rotate the entire animation and then draw the text flat. At least that's the way it looks like I'm doing it, but what it's actually doing is rotating the drawing frame. I think is a reasonably decent name for it, and as you keep rotating it, and then you draw some text, and then you rotate it a bit more, and you draw some text and rotate it a bit more. So so if you picture your piece of paper, and then you've got some overhead transparency. If anyone remembers what overhead transparency is, great. It's basically a flat transparent sheet of plastic. And normally the piece of plastic is lined up with your piece of paper and you draw on it and it's all great. What we're going to do is rotate that piece of plastic. Actually, I'm trying to think, is that a reason? I'm going to rotate that piece of plastic, and then we're going to draw on it, and then we're going to rotate that piece of plastic again, and then we're going to draw on it and rotate it, and then you'll see that as you do that, you'll end up with this trail of well, we're going to have month names obviously, so we're going to have, you know, January, February, March, April, May, right down to December, and we're going to do that 12 times. We're going to rotate it 1/12 and render a the text on that. So that's the goal. I'm just going to refer to some previous code that I have made before so that I can get this right. So I'm just going to check. I'm on a different computer to what's actually got my old spiral on. So this is the spiral code for the global seaice area. So down the bottom here. Oops, actually I want to zoom in on that so you can actually read it. So this is me, I called it clock, making a clock. So you can see that I basically draw January at -25,450. I rotate 1/12 of a circle, which is basically pi divided by 6. Now I draw February at the same point as what I drew January, except it's rotated by 1/6, and just keeps on going down. Rotate March, April, May, June, July, August, September. Now I could have done that in a loop, but it just works like this. In fact, I'm going to be cleverer now. I am going to draw it in a loop, and you'll probably get a better idea of what's going on than that. So let's do that. So first of all, let's create an array of strings called month names, which equals, I think I can just do that, yes, and then we've got Jan, Feb, March, April, May, June, July, August, September, and October. November and December. Right, that's January, February, March, April, May, June, July, August, September, October, November, December. It would be embarrassing if I got that wrong. Right, so now what we're going to do is loop through each of those. So for, do I get a for each? No. For int m for month equals 0, because arrays are 0 based, so that January is going to be 0. M is less than 12, so it only ever goes up to 11. M plus plus. Getting my curly brackets wrong. Got some people like it like this, some people like it like this. Me, I like it either way, and I get it mixed. Right. So obviously our month to render is going to be a string, and let's just call it month name, which equals month names square bracket m. Right, so we want to basically, right, where are we going to draw it? So why did I have those strange coordinates? And yeah, now why did I do that? Oh, I see, yes, yes, yes. Translate that, and then, so this is me before I actually understood much of what I was doing with that. So basically, this is right, I'm going to do this though. So translate is basically moving your piece of plastic, you know, so many pixels to the left and so many pixels down. Then this -25 is around about kind of half of what that width is going to be of about, so let's say that's going to be 50 pixels wide. I made it -25. What I didn't realize is that I can actually change the alignment of the rendering to be center, so center align, so then it will be just 0, -450. So when you translate, especially to the half width and the half height, that means that the X and Y origin are now in the middle of the screen. So then all you need to do is, and that's where it will rotate as well. That's why I've got to rotate here, but I've got no rotation point. The rotation point is defined by this translate. So let's do a better job of that. So first of all, let's go with setting the, now I'm going to do something a bit peculiar. I am going to do this. I'm going to do a push style. And I'm going to match that after this with pop style. What am I doing there? So this is a processing command that basically says, okay, given the style, now style is basically line color, line width, font style, like and alignment and all that sort of stuff. And what push style is basically saying, hey, remember the current state. And then after that, it's basically like sticking a save point in a game. So you're pushing it, and a push and pop are putting things on and taking things off, what they call a stack. So this is pushing onto the style stack the current state. That means that I'm free to modify as much as I like the style, which I'm going to do right now. I'm going to change the text align to be center. And that means that this has remembered the previous one, which is basically the text align wasn't center. I've now modified that to have the text align to be center, and then it's going to do all of its gubbins here, and then when it hits back to here, it's going to now pop the style, which basically means take off the stack the previous style. So that basically will stop. It'll basically set the text align back to the original thing. So do that instead of, so I could have done it like this. So I could have done it like that, get rid of that, and then afterwards I would have to tidy it back up and go to text align. I think would probably be left like that. So instead of having to remember to pair a text align with that, and that could possibly change, you know, that's assuming that left is the current state of the alignment, but up here I could change that text align to be right, and then sending it back to left would make no sense at all. So what we do instead is we just go push style. That just remembers whatever was set before, which happened to be text align, and then we're going to go pop style here, and that will just set it back to now. Now you can nest these a lot, so I could go text align center there, then I can go push style again, and then I can muck about with different text aligns, colors, what have you, whatnot, and then as long as each push style is paired with a pop style, you're good to go. So that's how that works. Alright, so that sets that to center. Now I'm going to do a translate. And you'll notice that I had these variables here of half width and half height. Alright, I'll show you why I did that. See that they're red and squiggly because they don't exist. I was using half width and half height so much, I realized I was calculating it all the time, so I just simply made a global variable available that works it out pretty much at the first thing it does. So we can do that. Oh, that's right, I remember now, fighting this, and then the width and the height was that. Oh, this is even before. Goodness me. This is code before I actually knew what I was doing. Wow. So that was width and height. Right. Should go back and fix up my old mistakes, eh? Right. Oh, I know why. I know why. Because width and height aren't set there. They're set. They're set there. Right. Okay. What I'll do is copy that, set those to 0, and then after that we'll set the values, and that means that whenever you change that we'll get the correct center points. So let's do that. Right, so we've translated half width and half height. Now what's going to happen is that when I do that, everything after render month names is going to have the origin at the center. So the way to fix that is very similar to push style and pop style. We also do a push matrix because we're working with matrix algebra when we're doing translations and rotations. So let's pop matrix as well, and that returns everything back to normal. It does undoes all of your translates, and it undoes all of your rotates and whatever other funky stuff that you've done. So This basically keeps everything correct. So I think if I look at my old code, I don't do that because I didn't know about it. Yeah, there we go. Translate negative half width and negative half height. Then this is done 1/12 rotation, so it's basically set it back to normal again. In fact, that last rotate there actually sets it back to normal. So there we go. I'm learning as I'm going. So now we don't have to worry about that. We've just got these two commands and it sorts everything out for us. So we want to draw text, our month name, comma 0 because it's center aligned, and a decent radius. And the radius, we'll go with negative 450 there. Because why not? It's going to be wrong, and then we'll adjust it accordingly. And then we'll rotate pi divided by 2, and that should draw us our month names in the appropriate place. So let's see what happens. Oh, yes, let's hit that. Didn't do anything at all, did it? Right, why was that? So we're in. Right. What I was doing, I drew the month names and then I cleared them, which wasn't very clever at all. So let's fix that up. Go there. Right. What do we got now? Interesting. Hey, what's going on there? Oh, I know. I did pi divided by 2, not pi divided by 6, didn't I? Stupid boy. There we go. Rotate pi divided by 6. There we go. Hurrah! We've got January, February, March, April, May, and that looks alright. So September, oh, actually I thought the September minimum was there, so that's saying it's July. Interesting. Why is that rotated just a bit weirdly? Feels like it's off by 2 months. Oh, maybe because 0. Probably that way. That seems to be north. Interesting. Right. It's probably my angle calculation. Angle of 1 month is 2, and then it's basically the month, which is 0. It starts off as 1. Multiply it by the angle of 1 month. Is it going clockwise or anti-clockwise? Let's slow that down and then we can watch what's going on. So let's knock it down to 5 frames per second. Can't actually tell which way around that's going. We're not doing any frame count stuff, are we? No, it was influence plus 10, that's the problem. Let's do that with 1, I should be able to see what we're doing. There we go, we're going anti-clockwise. Aha! Right, let's stop that. Right, go back to 10, and we need to make our angle negative. Right, that should look a bit different. Everything's all cock-a-hoop. That is peculiar. Right, so now September is here. But at least it's going around the right way. Okay, what we'll do, we'll stick that back down to 1, and we still have our frame clamp, right, so that's 5 a second. Right, so I think we start off in January, so January is here. That would be January, February, March, April, May, June, July, August, September, July, August. September is in that mess somewhere. January, February, March, April, May, June, July, August, September, Right, so we need to, why have we got that down there? That is really strange. So the month, 2 times 5 times 12. Where's the month? The month is 1. That's for thinking that might be just starting off with 0, but it's not going to change a huge amount. The month is going to be month mod 12. Let's make that to 0. I'm probably going to break something if I do that. That should adjust it a little bit. So now we're starting at May. Oh, why are we off by 1, 2, 3, 4 months? I don't understand that. Starting to lose my mind. Like this line here doesn't seem to be working. And oh, wait a minute. 0. I think it's 0 degrees is that way, isn't it? Why is it starting in May? Very big. Oh, wait a minute. Well, hey ho. So we want to change the angle by removing. Let's subtract 90 degrees, which in radians is half pi. Ugh, got that wrong. Let's say shall we add 90 degrees? Yeah, I think we'll add 90 degrees this time. Right, so we're getting closer, but it's still not January though, is it? Right, so now our minimum is actually on the right side of the dial, but still off by 1/12. How peculiar. Because the month is actually 1, isn't it? It's not 0. So when it's 1, it adds 1/12. So it is February. Right. So we go -1. That means that January will be 0, not 1. And we rotate it 90 degrees because 0 is horizontal. Okay, so I think actually the math is correct. So we want the angle so we want to have 0 to be vertical. So with that, with the month being 1, that's obviously making that 0, which will then make that 0 because we're multiplying by 0, which means that we add 90 degrees, which means we'll get a vertical value. So that's actually correct. Yes, there we go. There we go. Right. And we've got our minimum September-ish. Cool. Let's make that back to normal values. So that was, let's get rid of that, so that'll be 60 frames a second. And let's crack that up. This is drawing 12 months because that makes far more sense. So it'll be drawing 1 year per frame, so that will zip by quite quickly. And let's stop printing out those values because they're just completely useless. Hey, there we go. so we've got the September minimum. Great. And of course we've crashed. Still haven't worked out why that's the case. Right, that is a full hour. I think it's a reasonably decent part to stop. We've got ourselves a spiral with some color graduation and a good starting point for the next thing. What we'll do is just to make it a little bit nicer is to change our font size, because that was, I think is it text size or font size? Let's try that. Yeah, text size, and let's make it 40 point. Why not? So we can see the months and that. There we go. Probably a bit too big, but we can adjust that. So thank you all for watching. I will probably continue this next weekend, and what we'll do is add the global temperature spiral to this. Maybe we'll tart this up a bit with a bit more values. We'll put a circular grid in there so we can work out, so it shows the actual values of the sea ice area. We'll add the global temperature to the right of it, and that should probably do a decent weekend's work. Once we've done that, we'll see how how visually it looks. See if there's a good obvious correlation going on. We can adjust speed and values of that. What we'll also definitely add is the values between 2013 and 2018 now. And as that comes in, we can slow that down and hopefully be able to make an appealing animation, which I guess that will be a good thing, won't it? Right, I need to learn how to stop talking. So thank you all for watching, and we'll catch us next time. So cheers. Stop that. I've got to work out how to stop this cleaning. I think I